Welcome to my YouTube channel. My name is Michael Mwansa Lioba. Today we are going to look at arithmetic and geometric sequence or progression. To start with, I want to explain what a sequence is. A sequence is simply an ordered list of numbers. If you look at a distribution of numbers, the sum of terms of a sequence is called a series, and a sequence can be made up of random values, and others have definite pattern. Okay, so that's what we have. And you notice that when you are looking at this distribution of numbers, there are two special or typical series that stand out. These are the ones which we are referring to as arithmetic series or geometric series. So let's start looking at each one by one. We start with looking at the arithmetic series. So when you look at the arithmetic series, you are going to look at a sequence that follows a particular pattern, such that when you add a fixed a number or a fixed value to one term, you get the next term. And when you see that happens, then we refer to that type of pattern or series as an arithmetic sequence or progression. So some literature like to call it progression to indicate how the next number grows from the previous number. So some will say arithmetic progression. Let's look at an example here which has a series of 1, 4, 7, 10 up to the nth number. In this particular case, we refer to the first item in the series as the first term. In this particular case, we have 1 as the first term. Then the last number in the series, if it is n, that would be, if it's taking the position n, that is nth term, okay, or the last number n. As I've said, the fixed amount which is actually added to get the next number, okay, the name we call that number is called the common difference. It's known as the common difference. If you look at the above sequence, okay, where we have 1, 4, 7, and 10, we can obtain the common difference by looking at any two numbers in the series following each other. For instance, if we look at 4 and 1, the next term, which is 4, following 1, you subtract from the first term, in this case 1. You find that the difference will be 3. That's what we have here as 3. If you go to the next one, you get 4 and 7. When you look at the next number in this, when you look at these two numbers, you subtract the next number, which is 7, from, and you get, you remove 4 from 7, you are going to get again 3. If you happen to move to the next, which is 7 and 10, you get the following number, which is 10. Subtract 7, you still get 3. So you can see this is the number which is coming to be common difference between any subsequent number or two subsequent numbers. So that is called the common difference, and normally it's represented by the letter D to show that it's a common difference. We also have the rule of the nth term. When you look at the rule of the nth term, you are literally looking at how to determine a certain number in a particular position in that particular distribution or in that particular sequence. So we can determine that if we know the pattern, either it be arithmetic progression or geometric progression. We use a mathematical model that can assist us to determine what will be the number at the particular position in that particular series. So we look at this formula: a subscript n is equal to, that is the nth number, is equal to the first term, that is a1, plus the common difference d, then open bracket, then the number which we are looking for, n, and minus 1. The position of the number we are looking for, that is, we are looking at looking for a number at the nth position, and then subtract 1. So that's how you get that particular nth number, okay, in the arithmetic progression. So here we look at an example so that we see how this one is applied. I looked at the series 15, 10, 5, 0, negative 5. Okay, so if we apply the formula, nth number is equal to the first term plus the common difference multiplied by the portion of the number we are looking for, minus 1. In this case, let's assume that we are looking at what should be the number in the 9th position in this series. This is the how do we know what type of series we have? You start testing this one. So when you look at the difference between 10 and 5, you get 10 minus 15, you are going to get negative 5. So let's move to the next two numbers. We have 5 and 10. The next one is 5 following 10. So you say 5 minus 10, you still get negative 5. The next one is 5 and 0. So the next number to 5 is 0. So you say 0 minus 5, so you get negative 5. So we can conclude that negative 5 is the common difference D. So we apply it in this particular formula. We are looking at the 9th number, 9th term. So we're going to say the first term in this series is 15. So we have 15 there. Then the common difference is negative 5. We put negative 5 there. Okay, we put negative 5 there. And then the position is number 9 in the series. So 9 minus 1 will give you 8. So when you have this, you're going to have 15, then negative 5 times 8, which is negative 40. So there will be 15 minus 40, meaning that the number at the 9th position in this series is expected to be negative 25. Negative 25. If we look at the next example, which has a series of 1, then 3 over 2, then 2, then 5 over 2, then 3, etc. Again, if we want to know the 10th number in this series, okay, the 10th term, we're going to look at the formula again. The first term, which is A1, in this case is 1, and then the common difference. How do you get the common difference? You look at the two subsequent numbers in the series, then subtract this next one from the first one in that particular order. So you have 3 over 2. 3 over 2 is the same as, if you simplify it to be 1.5. So this is 1.5, 3 over 2. So subtract 1, you get half. You got the next one. There is a 3 over 2 and 2. The next two set of numbers, 3 over 2 and 2. The 2 is following 3 over 2. So we have said that 3 over 2 is 1.5. So we're going to say 2 minus 1.5. It will still be half. Okay? You go to the next one, which is the two sets of numbers. There is 2 and then followed by 5 over 2. 5 over 2 is the same as 2.5 or 2.5. So 2.5 minus 2, it should be half. So you can see that the common difference is 0.5, which is half. So we insert it in this formula. The nth term. Want to get the nth term. In this case, we want to get the 10th term in this series. So we're going to look at the first term, which is 1, as given in the formula. Then we're going to add the common difference, the product of the common difference and the difference between the 10th position in this case and 1. So we have 1 plus half times 10 minus 1. So half times 10 minus 1 will end up giving you 4.5. So which we add to 1, which will giving us 5.5. Means that the 10th number in this series will be 5.5. So that's what we do. So we also have another rule which has to deal with the arithmetic progression. We have just looked at the nth term or nth term rule. We are supposed to look at the rule of sum of terms. The rule of sum of terms. Now the rule of sum of terms is given by this formula, which is S, meaning sum, subscript n, meaning that sum of n numbers, okay, then equal to the n, the number of items we are going to add in the series, open bracket, the first term plus the last number, the nth number, okay. Then this sum is divided by 2. Okay, so where, as I've said, S subscript n is the sum of first n terms. Then A1 is the first term. N is the number of terms being looked for. And AN is the term itself. Okay, so that's what we have there. So let's look at this progression. The arithmetic progression. How do you know that's an arithmetic progression? We can teletest it. So how do we do that? We look at the first two numbers in the series. There's 5 and 9. So the second, the number which is following 5 is 9. So we say 9 minus 5, that will give us 4. If we look at, we move and look at 13 and 9. So when you subtract 9 from 13, we still get 4. If you look at 7 and 13, we subtract 13 from 17, we still get 4. So therefore 4 is the common difference. So D is 4. So what are we looking for? We are looking at the 10th number, 10th term in this particular series. So N is 10. So the common difference is 4 and the first term is 5. So 5 plus common difference is 4, open brackets, 10 minus 1. We're going to end up having 4 times 9, which is going to give you 36. Add it to 5, we're going to get 41. So that's how we work on it. Then if we now are asked to find the sum of the first 10 numbers in this series, we are going to apply the next formula, which is S subscript n, then equal to n, open brackets, first term plus the number itself at the nth position, then divide by 2. So we have the number at the 10th position as 41. So we're going to insert it in this formula. So the first term in this particular case is 5, and the n, the number of items we want to add are 10. So 10 open bracket 5 plus nth number is 41, then close bracket, divide that the result by 2. We are going to end up having 10 multiplied by 46 divided by 2, which is 10 multiplied by 23. Therefore we end up having 230. So that's the sum of the first 10 numbers in this series. Let's move to look at these are some of the examples I've looked at. Okay, and you can try these others for yourself. It will come back to the same thing. Okay, to come back to the same thing. You get up the results easily. Okay, then let's look at the geometric sequence or geometric series. Okay, a geometric series is one which follows a pattern where a fixed factor or a number to a term gives you the subsequent term. Okay, so a factor is a number that is applied to another number. So that's what we call a factor. So that's the case we have here. Okay, so let's look at how we deal with finding the nth term under geometric sequence, and also find the sum of terms under geometric sequence. So the rule of nth term is generated from this type of analysis. If you look at the first term to be a, okay, if you see that the next term, you get the next term by multiplying the first term with a particular fixed number r, then the next term will have a times r. If you are going to get the third term, you multiply again by this fixed term, fixed number, which is r. So if you are again multiplying r, you are going to get a times r, which gives you a r squared. If you want to get the next term, you are going to have multiplied by this fixed factor r. So you are going to get a times r, which is a r to the power 3. So now that is simplified in this formula. Any term in a geometric progression is the same as, is equal to a times the factor, okay, raised to power n minus 1. So I've said that n is the term being looked for. N is the term being, the nth term is n, or n is the term being looked for, where r is the common factor, which is known as common ratio. Okay, common ratio. So let's see how we play around with this particular series. Here I'm looking at these two examples. We have the first sequence, which is 10, 20, 40, 80, and so on and so forth. Okay. Now, how do we know the sequence we have here? Let's see if we can maintain, we can teletest it. So, is it an arithmetic sequence? Let's see. So, if you look at 10 and 20, when you subtract 10 from 20 to give you 10, let's move to the next one, 20 and 40. If you subtract 40 or 20 from 40 to give you 20, if you got the next one, you have 80 and 40. If you subtract 40 from 80 to give you 40, so you can see that you are obtaining different numbers. Therefore, it cannot be an arithmetic series. It cannot be an arithmetic series. So you rule out this sequence as an arithmetic series, as an arithmetic progression. So what is it then? Then use another test. Let's look at 10 and 20. So 20 is a double of 10. So it means that 10 is multiplied by 2 to obtain 20. Let's look at 20 and 40. Again, 40 means you doubled 20. So 20 was multiplied by 2 to get 40. Let's look at 40 and 80. 80 was a result of doubling 40. So 40 was multiplied by 2. So you can see that between all these two numbers, you are multiplying 2 by 2 to get the next number, the next term. So meaning that 2 is the common ratio. 2 is the common ratio. So it is a geometric series. So like before, we can determine the nth term in the geometric series. We can determine the nth term in the geometric series. Let's look at the example itself. Then 10, 20, 40, 80. Okay, so we have the first one, the first term, which is 10, then multiplied by the common ratio, which we have determined as 2. And if we want to know the seventh term, then n is 7 minus 1 here. So we are going to have 10 multiplied by 2 raised to the power 6. 2 raised to the power 6 is 64. Then multiplied by 10 to give you 640. So meaning that in this series, the 10th term is 640. The 10th term is 640. So let's look at the sum of geometric series. The sum of geometric series. So the formula to use for the sum of geometric series is S subscript n, which is equal to first term multiplied by the open bracket 1 minus r raised to the power n, and then divided by open bracket 1 minus r. Okay, so Sn is representing the sum of terms in the series. The sum of any numbers in the series, S subscript n. So that's what it is. Let's assume that we are looking at again coming from here, same example. In this series of 10, 20, 40, what will be the total or what is the sum of the first 10 numbers in this series? So that's why we are applying this one. So the first term is 10. So A1 is 10. Then we multiply open bracket 1 minus the common ratio we determine is 2. And how many numbers are we adding in the series? 10. So the power is 10. Then divided by 1 minus the common ratio, which is 2. So we are going to end up having 10 times, if you multiply 10 to the power 2 to the power 10, it will give you 1024. Subtracted from 1, it will give you negative 1023, and the denominator is showing you a negative 1. As that of subtracting 2 from 1, you get negative 1. So we end up having negative 1023 divided by negative 1, it will be positive 1023. Then multiplied by 10, it will give you 10,230 as the sum of the first 10 terms in the series. So that's how we deal with geometric as well as arithmetic progression. Thank you for listening. Please remember to subscribe to my channel and like my videos. Next time we meet, we're going to look at SADs, operations of SADs.